All right, have your textbooks open to page 70. Have your homework handouts out. You did 2 problems for homework. You did number 2 on page 70, which were some yes or no answers, I believe. And then you also had handout number 12 that you completed for homework. The handout looks something like this: 10 statements, reasons. I gave you 2 of the reasons and 8 of the statements. I'm going to hold the handout up so that I can see that it is completed. Hold the homework handout up. And waiting for... Excellent. And I believe you did the page 70 number 2. Was it on the back or did you do it in your books?
I did it in my book.
Most of you probably did it in your textbooks. I'll come around and check that in just a moment. All right, so you put your handouts down for just a moment. Let's go and review some things we talked about the last several lessons. We talked about really 2 ways of doing proofs. The main way, of course, is to have 2 columns of statements and reasons, and we're told to prove this, and line upon line, we, one thing at a time, methodically work our way to proving what we want to prove. There's another way to do a proof, though. What was that other way of doing a proof, Lana? It had a few different names. I'll take any name.
Indirect?
Indirect proof is the main name I want you to know. Do you remember the other names?
No.
Not really. Somebody else remember the other names? Brandon?
Informal and proof of contradiction.
Okay, informal and proof by contradiction. What was the general gist to this informal proof or indirect proof? Brecken? And then... Yeah, okay, so kind of, yeah. Start by assuming the opposite of whatever you're actually trying to prove, but then by arriving at a contradiction, show that that assumption must be wrong. There's no way for that assumption to be true. Prove the assumption impossible or even ridiculous. We then talked about a statement that is formed by taking some other statement that's true, taking a truth, and switching or interchanging the hypothesis, the if, and the conclusion, or the then. What do we call a statement formed by switching the if and the then? Josh?
Converse.
Got a converse statement. Are converse statements always true, class? No, I did tell you, though, a converse of a blank will always be true. Dylan?
Definition.
A definition. So if you take a definition and make a converse out of it, of course, that'll always be true, as long as it's a complete definition, right? We looked at one where I think it was the an obtuse angle is less than a straight angle. Is that true? It's not the definition, though. So if you said an angle less than a straight angle is obtuse, well, that's not true, right? Because it could be acute or even right. So whole definition converses are still true. Then in our last lesson, we started looking at lines that are everywhere the same distance apart and never intersect. What are these lines called, Adam?
Parallel.
Parallel lines. And we said that through a point, how many lines could I draw parallel to that line? Noah? One and only one. Now we said there's really no way to prove this, that there's only one line, but we all agreed that it seemed to us like that would be true, so we accepted this geometric statement without proof to be true, so we called this, then Abby, a postulate. Specifically called it the parallel postulate. Based on this, though, we said that if 2 lines are parallel to the same line, class, they've got to be parallel to each other, or else that would violate the assumption that we made in our parallel postulate. We then talked about having a couple of lines, and whether they're parallel or not, and drawing a third line to intersect those first 2. What do we call a line that intersects 2 or more other lines? Michael? Josh?
Transverse.
Oh, okay, transversal. Class, say that word with me. Transversal. So a transversal is a line that cuts through other lines, and it forms, of course, with each of the lines, it forms 4 different angles. And we said that the angles 1, 2, 7, and 8, since they're on the outsides of the lines, class, those are called exterior angles, and angles 3, 4, 5, and 6, since they're between the lines, we call those interior angles. Specifically, though, an angle like angle 2 and angle 7, they're both exterior, but they're on opposite sides of that transversal. How would I describe the relationship between 2 and 7? Dylan?
Alt exterior angles.
What is alt the abbreviation for? We would write alt, x angles, but what does that stand for? Want to help him? She's like, I just remember the abbreviation.
Alternate exterior.
Good. Alternate exterior angles, class. What would these be?
Alternate exterior angles.
Okay, so angle 4 and angle 5. Okay, again, not necessarily equal, but 4 and 5, they are both between the lines, but they're still on opposite sides of the transversal. 4 and 5 class would be called alternate interior angles. What about an angle like, say, 1 and 5? Again, not necessarily equal in this case, but they're in matching spots. One's exterior, one's interior, but they're both above the respective lines, and they're both to the left side of the transversal. So 1 and 5 would be called, Noah? Corresponding angles. Good. What would be the corresponding angle of 4, class?
8.
Careful. 8. Because 8 is below the line like 4 is, and it's to the right side of the transversal. They're in a matching spot. What about angle 3's corresponding angle? 7, because they're both below and to the left. And of course, angle 6 has as a corresponding angle angle 2, because it's above the line like 6 and to the right side of the transversal like 6. They're in matching positions. And we were working on proving some things that if you had 2 straight lines cut by a transversal, and you happen to have alternate exterior angles equal to each other, if they were equal, then what would have to be true about the lines, class? They'd be parallel. If alternate interior angles were equal, we proved lines would have to be parallel. What if the alternate exterior angles were equal, class? Lines would have to be parallel. What if corresponding angles were equal? What would have to be true? Lines would have to be parallel. So we were proving some things about parallel lines, or proving that lines are parallel if these different things are true. Page 70 at the bottom of the page, number 2, it gave us that little picture. Now the picture is actually in the second column, and it made M and N appear to be, so you only circled the one that you said was true. Okay. Gotcha. I was like, not quite sure what you're doing there. Okay. But they look like M and N are parallel, but we don't trust our eyes. So the question was, are M and N parallel lines if, and letter A said if angle 4 is 70, and if angle 7 is, or excuse me, angle 6 is 70. So angle 4 was here and angle 6 was here. If these two angles are both 70, are the lines going to be parallel? Abby? Why? Which theorem or corollary tells us that? Good. Theorem 7. If alternate interior angles are equal, lines are going to be parallel. How many had yes for letter A? All right, letter B says if angle 3, that's right here, is 110 degrees, and if angle 7, that's right here, is 110 degrees, then are the lines going to be parallel? Yay or nay? Adam, your verdict? Yay, they will be parallel. Because what kind of angles do we have here, class? Corresponding. I believe it was corollary 7-2 said if corresponding angles are equal, lines are going to be parallel. Again, we're going off of my corollaries. I differ from the book a little bit. Let's see, letter C, if angle 2 is 70 degrees, and if angle 8 is 70 degrees. Are the lines going to be parallel, yay or nay, Brecken? Why? If alternate exterior angles are equal, lines are parallel. I believe that was our first corollary, wasn't it? Corollary 7-1. So yes, those have to be parallel. So far we're perfect. Yes, yes, yes. Letter D, we had 110 degrees at angle 1, and we had 60 degrees here at angle 8. Now, the 110 and the 60, they're not special in any way, are they? They're not corresponding. They're not alternate interior. They're not alternate exterior. They're nothing special. But I do know what, for instance, about these two angles, class. If this is a straight line, which it assumes by calling it M, which is how we name a straight line, then it must add up to a straight angle. So what is the measure of this angle here, class? It'd have to be a 70-degree angle. Well, what kind of angles are these two, class? Corresponding. And if corresponding angles are equal, class, then lines are parallel. But if they're not equal, then class, not parallel. So letter D, no, for the first time, not parallel. How many letter D is a no, not parallel? And letter E, well, what if angle 1 is 110 and angle 6 is 70 degrees? Well, stick with what we just said. If this is 110, then this adjacent angle would have to be 70. What is the relationship between these two angles, class? Alternate interior. And if alternate interior angles are equal, class, lines are parallel. These are equal, so the answer, of course, would be yes. So A, B, C, and E were all yes. D was the only no vote. Questions on those? How many got all 5 of those questions correct?
I just missed one.
Does it make sense now that we've talked through it? Any questions at all on that? All right, let's take a look at the handout, and then we'll finish a couple more corollaries that we just didn't have time to get to. Going to have your handout out, and got an isosceles triangle, kind of a shorter, flatter isosceles triangle here, and we were told that AC is equal to BC, but then we were also given these equal lengths marked off to D and E. And those little pieces, CD and CE, were equal. And then lines were drawn from B to D and from A to E. And of course, those two lines are going to intersect somewhere. We called this point O. And the goal was to prove that this triangle, formed by the intersection of the lines, was indeed isosceles. So obviously your first statement, AC equals BC, DC equals EC, reason was given. Just saving you some writing there. You obviously knew what that was going to be anyway. For sake of time. Okay, number 2. Told that angle C is equal to angle C. What was your reason for number 2? Lana?
I put identity.
Identity. Any quantity is equal to itself. Now on the surface, you may be like, well, that's a strange thing just to go straight to an identity. But when you look at number 3, the goal was to get triangle ACE congruent to triangle BCD. And what was the reason that, hold on there, ACE, that's this triangle, was equal to BCD, that triangle. Why are those two, the yellow outline and the yellow shading, why would those two triangles have to be congruent to each other? Josh?
Side.
Good. The entire side here equals this entire side here. And then this little piece of the yellow equals this little piece of the yellow shade. And then in between we have angle C and angle C. So side, angle, side. How many have that reason? For number 3. Now the real question would be, why would we try to get these two little slivery triangles congruent? And the question's answered with the very next thing. I said that this angle 1 and this angle 3 are equal to each other. The reason here, Dylan, of course, is, yeah, we just got congruent triangles. Now we're saying that some corresponding angles or corresponding parts of those congruent triangles are equal. How many at CPCTE for the reason they're on 4? And now on number 5, I actually come back to a claim and say that the whole angle at A equals the whole angle at B. Why is it true that this angle A and this angle B are in fact equal to each other? Michael?
If equals or other 2 equals or some equal.
Ooh. No, Abby?
And a triangle, angles opposite equal sides are equal.
Go back to the whole big triangle. This normally would have been a claim. This normally would have been number 2. Because in the given, right, it says that AC equals BC. So it should have been right away, oh, BC is across from A, AC is across from B. In a triangle, angles opposite equal sides are equal. And that's what we should have had there for number 5. Now, are 1 and 3 in the same triangle class?
Yeah.
So we wouldn't say that 1 and 3 are equal because in a triangle, angles opposite equal sides are equal. Those are in 2 separate triangles. But you see that the whole angle A and the whole angle B are in the same big triangle, right? So that's the reason there. And then from there I said number 6, well, what is A? Well, it's 1 plus 2. And what is B? Well, it's 3 plus 4. How do I know that A is 1 plus 2 and B is 3 plus 4? Back to Michael for redemption.
I put the whole equal to the sum of all its parts.
Yeah, absolutely. The whole is equal to the sum of all its parts. But keep in mind, here's the analysis that was kind of unseen that maybe you thought through. Well, I know this whole angle equals this whole angle. Clang, equal sides, equal angles, right? And if I could get the little slivery triangles congruent, by side angles side, then I can say this little piece equals this little piece, right? And then if I could take the little pieces off of these whole equal angles, what would I be left with, class? Eventually, if I take the little piece 1 and little piece 3 off of A and B, what's going to be left? And if 2 and 4 are equal in this triangle, then A and B are equal. We've got an isosceles triangle, right? That's kind of the analysis. So it starts with, well, A and B are equal. What is A? What is B? Whole equal sum of parts. And then since A is 1 plus 2, plug it in there. Since B is 3 plus 4, plug it in there. And that's what we should have done for our substitution. On number 7, we should have said that 1 plus 2 equals 3 plus 4. How many had that as your statement on 7? Because since 1 and 3 were equal earlier, I can just take off a 1, take off a 3, and number 8, we did have angle 2 equals angle 4, but what's the reason on that one there, Josh?
Subtraction.
Subtraction axiom. Or just subtraction. And if that's true, if the angle at 2 equals the angle at 4, then this side has to equal this side. So number 9, OA equals OB. Brecken, the reason?
Sides opposite equal.
Well, sides opposite equal angles in a triangle are equal. And if A and B are equal, 2 equal sides, what do we call that triangle, class? Number 10, triangle OAB is isosceles. And our reason, anyone? Definition of isosceles triangle. The hard part of this would have been, if you'd done it by yourself, was thinking to get the little slivers congruent right up front. But again, what's the key to getting isosceles, class? Get 2 equal sides. What's the key to getting 2 equal sides? 2 equal angles. What would be the key to getting these 2 angles equal? Well, if you know by Klang that the holes are equal, gotta find a way to get the little pieces equal. That way I could subtract them off. How to get the little pieces? Side, angle, side. Gets the little slivers congruent, so 1 and 3 are equal, and then the rest of the proof kind of flows into place. Was anyone perfect? You had 10 total blanks to fill in. Anyone go 10 for 10? How about 9 for 10? Just missed one of the blanks.
Well, I swapped 4 and 5, like the reasons.
Ah,
I put
okay.
them backwards.
Do you see that 1 and 3 are in these 2 triangles? So they're the corresponding parts of congruent triangles. A and B aren't. A and B, by the way, could have been stated right up front, right? Right off the bat, statement number 2, we could have put that because it was Klang. Just the way I set up the proof, I ended up not getting around to it till number 5. Question, Adam.
I got 3, 4, and 5 wrong because of the one thing.
What was your reason for 3?
I was.
What did you write?
I said addition axiom because
For congruent triangles? Your only options are SAS, SSS, and ASA. Unless I'm right, then it's LL and LA.
I thought they were angles. That's what happened.
Oh, yeah, triangle symbol there. Okay. All right, that kind of makes sense. Be careful in your reading, right? Good. Any other questions, comments? All right, go and set that proof aside if you would, and take out your notebooks. Turn back to Theorems Corollaries section. I gave you 2 corollaries for Theorem 7, and then we ran out of time. Burned by the bell. So we're going to go ahead and knock out those last 2 corollaries here now. So you've already got corollary 7-2. Go ahead and write corollary 7-3. Corollary 7-3 says this. Lines perpendicular to the same line. Lines perpendicular to the same line are parallel to each other. Lines perpendicular to the same line are parallel to each other. Statements like this, you're thankful for shorthand. Oh, always thankful for what? Lines perpendicular to the same line are parallel to each other. For sake of time, we won't do the proof, but I do want to talk through the proof. Let's suppose that's a perpendicular. And let's suppose this is also a perpendicular. I want to prove those 2 lines are parallel. Now, they look parallel, don't they? But that's not good enough, right? We'd have to prove they are. Begs the question, what does perpendicular actually mean, Brandon? Lines that form right angles, right? So we would say that angles 1, 2, 3, 4, those angles are class right angles. Now, thinking of this line as a transversal, what kind of angles are 2 and 4? Corresponding angles. And we proved in corollary 7-1, that corresponding angles, if they're equal, then lines are parallel. What do we know about all right angles? So therefore, angle 2 equals angle 4, right? Because they're right angles. And if corresponding angles are equal, lines are parallel. So that's the quick proof of corollary 7-3. Lines perpendicular to the same line class are parallel to each other. Corollary 7-4. This one's a longer one, sorry. Corollary 7-4. If, comma, when two straight lines are cut by a transversal, comma. So it starts off the same way as Theorem 7, Corollary 7-1, and Corollary 7-2. If, comma, when two straight lines are cut by a transversal, comma, the sum of two interior angles, the sum of two interior angles, if when two straight lines are cut by a transversal, the sum of two interior angles on the same side of the transversal, the sum of two interior angles on the same side of the transversal, if when two straight lines are cut by a transversal, the sum of two interior angles on the same side of the transversal equals a straight angle, the sum of two interior angles on the same side of the transversal equals a straight angle, comma, then the lines are parallel. If, when two straight lines are cut by a transversal, the sum of two interior angles on the same side of the transversal equals a straight angle, then the lines are parallel. Again, we'll talk through the proof. If, when two straight lines, A and B, are cut by a transversal, T, the sum of two interior angles on the same side of the transversal equals a straight angle. If these two angles add up to a straight angle, then it says the lines are going to be parallel. Well, I'm going to go ahead and call this angle 3. What do we know about 1 plus 3, class? Straight angle. Why? Informal statement 10 tells us that the sum of all the angles about a point on one side of a straight line equals a straight angle. So we know that angle 1 plus angle 3 equals a straight angle. We were given angle 1 and angle 2 added up to a straight angle. What do we know about all straight angles, class? They're equal. So therefore, I know that angle 1 plus angle 2, that's an angle symbol, equals angle 1 plus angle 3, correct? But I know angle 1, of course, equals itself, right, by identity. So therefore, I could subtract equal quantities from equal quantities. And what would I be left with, class?
Angle 2.
Yeah, angle 2 equals angle 3. You were right. All right. Well, question, what kind of angles are 2 and 3? Alternate interior. What did Theorem 7 say? If alternate interior angles are equal,
They're parallel.
lines are parallel. There's proof. Lines have to be parallel. Questions on that? All right. Now, let's take all of this and summarize. Class notes section. Class notes section. Let's summarize 6 ways to prove lines parallel. So find a spot where you've got, I don't know, 6, 7, 8 lines worth of space in your class notes section. It doesn't have to be a brand new page, unless you want it to be, that's fine. However you want to organize it to make it easier to study. 6 ways to prove lines are parallel. Because think about it, you're going to come across a proof and it's going to say prove these 2 lines parallel. It'd be nice to have some ways to use, right? Kind of like when we come across prove triangles congruent. What are my ways to prove triangles congruent? We rattle them off, right? What are some ways to prove lines parallel? Number 1, if they are parallel to the same line. If they are parallel to the same line, then they're going to be parallel to each other, right? So that's one way to prove lines are parallel. Another way is if they are, as we just showed a moment ago, perpendicular to the same line. If they're perpendicular to the same line, it's a terrible perpendicular symbol. If they're perpendicular to the same line. Number 3, if alternate interior angles are equal. Really, we only need one pair. If you can get any pair of alternate interior angles equal, then they're going to be parallel. Theorem 7. If alternate exterior angles are equal, then they're going to be parallel. Number 5, if corresponding angles are equal, then they're going to be parallel. And the last way is the awkwardly long way, but if the sum of two interior angles on the same side of the transversal equals a straight angle, then they're going to be parallel. If the sum of two interior angles on the same side of a transversal equals a straight angle, then they're going to be parallel. There's a wall there. Just trying to help y'all out. All right. So go and get that copy down in your class notes section. And make a great quiz question, you know? Write out the 6 ways to prove lines are parallel.
That's a lot, right?
Yeah, well, I can make it worth 6 questions, though, right?
That's still a lot.
Yeah. All right, then I only have to come up with 4 more questions. I got a 10-question quiz.
Oh, I think
Easy.
we're good.
Yeah, this is great. This is great.
I think we're
Or if we're shooting for like a 30 or 40 question test, I've got 6 of my
Oh.
questions right there. This is great.
I don't,
All right.
I don't think so.
You should do it, Lana. You have an answer key, right?
You have the answer key right here, Lana. Just memorize them, right? Easy. Easy.
Memorize, but if we have it there.
All right. All right. Anyway, questions on those. Again, none of those did we actually work out the proof. Are we good to go on the talked through proof?
Yeah.
All right. Theorem 8 in your notebooks. Let's go conversely on all of this then. Let's prove that converses of these are also true. So theorem 8 in your notebooks. Theorem 8 says this: if two parallel lines are cut by a transversal, if two parallel lines are cut by a transversal, if two parallel lines are cut by a transversal, then the alternate interior angles formed are equal. If two parallel lines are cut by a transversal, then the alternate interior angles formed are equal. Do you see this is the converse? If lines are parallel and cut by a transversal, then alternate interior angles are equal. Earlier we said if two lines are cut by a transversal and the alternate interior angles are equal, then the lines are parallel. If the lines are parallel, alternate interior angles are equal. Earlier we said if alternate interior angles are equal, then lines are parallel. Make sense? Again, for sake of time, we'll just show the proof. But let's suppose we know, call these lines A and B, we know that A is parallel to B. And we cut these two parallel lines by a transversal, let's call it T. And let's suppose I wanted to prove that these two angles are equal to each other. So I got these two parallels. I want to prove the alternate interior angles are equal. Well, let's go indirect method again. We're on a roll with that. If I went indirect method, and we're just going to talk through indirect method here, but if I went indirect, what would I start out by assuming, Dylan?
That A is not parallel.
Well, we're given A is parallel, sorry. We're given A and B are parallel. We're trying to prove that 1 and 2 are equal.
Why is that?
Yeah, so let's just assume for a minute, you don't have to copy this down, but let's assume angle 1 doesn't equal angle 2. What does it mean if angles are equal? What is the definition of equal angles? Anyone?
Opposite angles are equal.
The definition of equal. What makes angles equal, Abby? If the sides can be made to coincide.
Yeah.
So in other words, if these angles were equal, then these two sides, if you could pick it up, would equal those two sides. Make sense? But they're not equal. That's what we're assuming at least. We're assuming they're not equal. You know what that means? Their sides don't coincide, right? So either one is a little bit bigger or one's a little bit smaller, but one is not equal, correct? Well, if it isn't equal, does it make sense that through this point we could make an equal angle, right? Using this line and this line, I could make this exact amount of rotation here. I could make an angle that's equal, right? Or I could, if this angle was too big, I could make an angle that's equal. Either way, right? So angle 1 is this angle right here. I'm going to draw or construct an angle equal to the other one. It's either going to be here as 3 or here as 3. Either way, right? But I could construct angle 3 at whatever this point is. Let's just call it P. Construct angle 3 at point P so that angle 3 equals angle 2. Everyone agreed? If one ain't equal, I can make an angle that is. Y'all good? Well, question. If angle 3 is this big one, then what does that mean about this line? Well, it means that alternate interior angles are equal. So what has to be true about this line, class? If angle 3 is equal to angle 2, as we just constructed it to be, what does that mean about this line? It's got to be parallel to B, correct? Or, if angle 3 is along this line, what does that mean about this line? It's got to be parallel to B. Either way, however you construct angle 3, whatever line is used to do the construction has to be parallel to B, correct? But wait a second. We were given that A was parallel to B. So if I call this C, can C be parallel to B also? Because the parallel postulate says through a point P, only one line. So if A is already that line, you can't construct another line that forms an equal angle because that would give you two parallels. Make sense? You can't have two parallels, so therefore angle 3 can't be a different size than angle 1. Angle 1 and angle 3 are the same angle, therefore angle 1 must equal angle 2. Questions on that? Does that make sense? Follow the logic? All right, corollary 8-1. Corollary 8-1. If two parallel lines are cut by a transversal, if two parallel lines are cut by a transversal, if two parallel lines are cut by a transversal, then the corresponding angles formed are equal. If two parallel lines are cut by a transversal, then the corresponding angles formed are equal. All right, so we just said if A and B are parallel, then angle 1 has to equal angle 2. We showed there's no other way, because if it weren't equal, you would draw another line so that they were equal, so that the other angle were equal. Now we give you two parallels. That can't be possible. 1 and 2, these alternate interior angles, have to be equal. Well, now we want to prove angle 3 equals angle 2. We just proved 1 would have to equal 2, right? Thoughts? Brecken?
I think, like, Abby or somebody.
No, you. What? I know that if A and B are parallel, we just proved in the theorem 1 and 2 would have to be equal. Anything else is ridiculous. But now I want to prove that 3 equals 2.
Oh, no, not
What vertical angles are you talking about?
I'm thinking wrong.
Are you?
Oh, no, because angle 1 equals angle 2.
Yeah, we're given angle 1 equals angle, or well, that we weren't given, but that would be, if this is given, then this would be statement 2, that 1 and 2 are equal because alternate interior angles are equal if lines are parallel. We just proved it, theorem 8. All right, so what would be statement 3?
Angle 1 and angle 3 are vertical angles.
Well, angle 1 and angle 3 are equal because they're vertical angles, right? And so if we know that 1 equals 2 and we know that 1 equals 3, class, 2 equals 3 because quantities equal to the same quantity are equal to each other. Or you just make a substitution, plug that in there, and boom, you've got 3 equals 2. Okay, so either substitution or quantities equal to the same quantity. Really easy. What is that, 4-step proof if we've taken the time to do it? Questions? Corollary 8-2. Corollary 8-2. If two parallel lines are cut by a transversal, you saw that coming. If two parallel lines are cut by a transversal, then the alternate exterior angles formed are equal. If two parallel lines are cut by a transversal, then the alternate exterior angles formed are equal. So if we're given parallel lines, then statement number 2, I know alternate interior angles are equal, right? That's theorem 8. We proved that indirectly. Then, well, we know 1 and 3 are equal, kind of like Brecken said, but we also know, class, that angle 2 has to equal angle 4 because they're also vertical angles, and vertical angles are equal. Not definition of vertical angles. And then take 3 and in for 1, and we take 4 and in for 2, and boom. By a double substitution. It's one step, but we just substitute two different things at the same time, and it's still a 4-step proof. Angle 3 equals angle 4, alternate exterior angles are equal. Questions on corollary 8-2? Corollary 8-3. If two parallel lines are cut by a transversal, comma. If two parallel lines are cut by a transversal, then the sum of the two interior angles, on one side of the transversal, then the sum of the two interior angles on the same side of the transversal equals a straight angle. If two parallel lines cut by a transversal, then the sum of the two interior angles on the same side of the transversal equals a straight angle. So I might want to prove that angle 2 plus angle 3 equals a straight angle. Well, if we're given parallel lines, then per theorem 8 class, we know that the alternate interior angles have to be equal. We also know, thanks to informal statement 10, that the sum of all the angles about on one side of a straight line equals a straight angle. So we know number 3, that angle 1 plus angle 3 equals a straight angle. What would I do to get angle 2 plus angle 3 equals a straight angle? Substitute 2 in for 1, and we've got it in 4 steps again. So a lot of little 4-step proofs, if we take the time to do them, written out. Questions on that? Corollary 8-4. Corollary 8-4. A line perpendicular to one of two parallel lines, a line perpendicular to one of two parallel lines is perpendicular to the other also. A line perpendicular to one of two parallel lines is perpendicular to the other also. A line perpendicular to one of two parallel lines is perpendicular to the other also. Here's the idea. I got A, I got B. A parallel to B. I have line C. C is perpendicular to A. We want to prove C is perpendicular to B. Now, quick word of caution. A lot of students be like, ooh, we just substitute. Since B and A are parallel, just put B in for A, right? What is substitution? A quantity may be substituted for its equal, not its parallel. So you can't just do a substitution here. But if we know that A and B are parallel to each other, right? And we know that C is perpendicular to A. What does perpendicular mean, class?
Right.
Right angles, correct? And so we call this angle 1. We know that angle 1 is a right angle. All agreed? Perpendicular. But we also know if lines are parallel, we proved, I think it was corollary 8-1, that corresponding angles are equal. So therefore, if 1 and 2 are corresponding angles, class, I know that angle 1 and angle 2 are equal. Well, if angle 1's a right angle, and angle 2 equals angle 1, then by substitution, class, angle 2 is a right angle. Well, if angle 2 is a right angle, then what's got to be true about these two lines? They got to be perpendicular, because what kind of lines form right angles? Perpendicular. There we go. And let's see, that would be 1, 2, 3, 4 steps again. Well, given 2, 3, 4, 5 steps to prove corollary 8-4. Questions on that? A lot of little facts, right? That once you get the 1, once you get those alternate interior angles equal, oh, then this must be true. Once you get the lines parallel, okay, then if this is true, then this must be true. So a lot of stuff, a lot of corollaries to those theorems. Questions on perpendicular lines and such. Now, the neat thing about this is it lends itself toward actually doing a little bit of math. So, if you would, on another sheet of paper, this can go in class notes if you want to, draw a couple of lines that appear to be parallel. We'll call them x and y, and we'll say that x is parallel to y. And I'm going to draw a couple of lines like this, a couple of transversals. We'll call this T, and we'll call this R. All right, so we got a couple of transversals, T and R. Let's suppose we know that this angle right here is a 55-degree angle. And let's suppose we know that this angle here is a 100-degree angle. I'm going to number these angles 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have 9 angles that we want to find. This isn't terribly unlike Sudoku, which some of you, I've been doing some of those with my Algebra 1 students lately, where you figure something out, and because you figured this out, then you also figure that out. Once you figure this out, you got to figure that out. So we're just going to kind of figure it out one thing at a time. Make a little list. Angle 1, angle 2, angle 3, angle 4, angle 5, angle 6, angle 7, angle 8, angle 9. We're just going to go one at a time. Not in order necessarily, but just, hey, I know this angle must be this big because. And we'll start with our senior citizen in the class, Michael. Give me any angle you say, I know how big angle blank is because.
I know how big angle 8 is.
How big is angle 8, Michael?
55 degrees.
Gotta be 55 degrees, Michael. Why?
Because it is the corresponding angle.
To the given 55. How many saw the corresponding angles that Michael saw? All right, so angle 8, got to be 55 degrees. No doubt about it. All right, and then let's go to, let's see, we got some juniors in here. Let's go to little sister Abby. Little sister Abby, what's another angle you know how big it is? Angle 2 is 100. How'd you get 100 degrees for angle 2? Its corresponding angle to this given 100. So we know angle 2 is 100 degrees. So brother and sister both went corresponding angles on me. Let's see here. We got a couple brothers in here. Let's see. Older brother first. All right. So Dylan, senior spokesman of the pair. Brandon resented. All right. So, all right. The older shall serve the younger. What is that Brandon said? It's biblical, I suppose. Oh, just in that case. Just in Jacob and Esau's case. All right. So Dylan, what's another angle you know how big it is? How big is 6?
55.
How do you know it's 55?
It's vertical from 8.
Okay, it's vertical from 8, or if you looked at the original 55, it would be alternate interior. Either way you want to look at it, doesn't matter. The point is we know angle 6 is 55 degrees. All right, then we go to the younger brother, Brandon. 6 minutes younger, is that right? 1 minute younger. Wow, that was quick. All right. 1 minute younger. Where did I get the 6 number from? I don't know. Anyway.
Angle 5 is 125 degrees.
How'd you get 125 degrees?
Well, there's two ways you can subtract 180 from the 8.6.
Okay, good. We know that together we have a straight angle here, or together we have a straight angle here, or We have a straight angle here because the sum of the two interior angles on one side of a transversal equals a straight angle. Either way, we know angle 5 is 125 degrees. Let's see, Brecken. You're a junior. You're up next.
Angle 1 equals 80 degrees.
Okay, how did you get 80 degrees for angle 1?
Angle 1, angle 2, straight.
Angle 1 and 2 is a straight angle. If angle 2 is 100, then angle 1's got to be 80 degrees. Good. All right, Noah, L Junior. Give me another angle we know.
Angle 7 is 8.
How'd you get 80 degrees for angle 7? Okay, if you look right here, you got a straight angle, right? Or angle 1 and angle 7 are corresponding angles. You could have gotten it that way too. All right, now we go to the young ones in the class.
No.
Who's the oldest of the young
I'm
ones?
the youngest, so it would probably be
Adam or Josh?
It's Josh.
Josh is the senior statesman of his class. Joshua. Anyway, angle 3, 4, or 9. Hey, that's perfect. We have 3 angles left.
9.
Okay, how big is angle 9?
125 degrees.
125 degrees. How do you know?
Vertical.
It's vertical to angle 5, or supplementary to 6, however you want to do it. But angle 9 is 125 degrees. Now, Lonnie, you said you're the baby. So, Adam.
Angle 4 is 45 degrees.
How'd you get 45?
Because the 100 is vertical from.
Right here. And I was curious how we were going to approach this when there's a number of ways to approach it. But do you see that these two are vertical to angle 2? Do y'all see that? So if we've got 100 at 2, then collectively they have to make 100. Therefore, you said angle 4 is 45 degrees. There's a few other ways we could have gone. I want to go ahead and discuss them with you. The other way would be similarly to say that these two collectively are alternate interior to this 100. Or you could say, and we haven't proven it yet, but in a triangle, the sum of the 1, 2, 3 angles adds up to 180. Well, we already had 135 degrees used up. That left 45 degrees for the other angle in the triangle. So there are a few ways to approach it. Lana, that leaves you with angle 3. The youngest in the class doesn't get a choice. You get stuck with whatever you get. It's like, everybody else is taking steak and all the fancy food. You get tuna fish. All right,
Wow.
So here's the tuna fish. Angle 3.
It probably equals another one.
Well, what does it equal and why?
Probably, it would be 100.
Why not?
Maybe it is.
Okay, then why?
Because the one below it. Wait, no. Never mind. What would it then?
Would it equal 100? Why would it equal 100?
Because the corresponding one?
What's corresponding to angle 3? Does 3 even have a corresponding angle, class?
Is it 2?
No, if there were a corresponding angle, it would be down here, and there's not a corresponding angle to 3. So no, we don't actually have a corresponding angle. Maybe an alternate interior angle? Do we have an alternate interior angle?
No. Actually, was 7?
7 would be alternate interior, wouldn't it? Okay. So in that case,
It is.
ooh, what do we know about alternate interior angles of parallel lines, Lana? Alternate interior angles are equal, and if 3 and 7 are, as you said, and they are, alternate interior,
That would be 8.
that'd be 80 degrees then. There's another way we could have gotten it. Anyone? Call it?
7 to 1 equal 2.
Okay, you could have said vertical to 1 or supplementary to 2. So a few different ways you could have gotten the 80 there.
The ones on the outside were kind of throwing me off a little bit.
Which ones are those?
Like the 125 and the 100.
Okay, well, just realize, stay with me. Just realize that the 55 here and the 125 add up to 180, just as the 80 and the 100 add up to 180, just as this 180 add up to 180. So anytime you see a straight line, locate a point, everything around it has to equal 180. Right, so looking for those. You're going to have a similar problem for homework this evening. For homework, do page 74, number 12. Page 74, number 12. It's an exercise like this. Now, in addition to the written homework, study over pages 61 to 72. Study over pages 61 to 72. And Gavin, I will be emailing your mom your first quarter geometry notebook check sheet. For the rest of you, I'm passing it out to you. This is kind of a summary list of what I'm looking for in your geometry notebook on Friday. So 10/7/22. Gavin, obviously you got a little bit more time since you're a little bit behind us, and that's fine. But it also gives you the point breakdowns of how much each of those things are worth. Take a look very quickly, and then I'll let you go. Notice, neatness is worth 10 points. If it's sloppy, if it's hard to read, if pages are torn, if the sections are out of order, if things are mislabeled, those 10 free points come down. Turn it in on time on Friday, 10 points. So what if Friday comes, you're like, I ain't ready. Well, if you don't turn it in on time, you lose 10 points. You're like, well, I'd lose 50 points if I turned it in like it is. And by all means, wait till next week. But get it done on time. You got all week to get it ready. The only reason you should be behind is if you missed days. So if you've been here every day, you should be right on. If you're behind, this is your last call. Get it ready. By Friday, 2 quiz grades on Friday. So begin making sure the notebook's ready. Study pages 61 to 72. Page 74 to number 12. You are dismissed.